Here we discuss the basic axioms of probability. We have three basic axioms of probability, which is 1. The first axiom of probability states that the probability, say, of A is less than or equal to 1. The second axiom of probability states that the probability of a sample space is also equal to the probability of A, which is 1. That means the probability of a sample space is equal to 1. And the third axiom of probability states that if A intersection B is an empty set, then the probability of A union B is equal to the probability of A plus the probability of B. So these are the three basic axioms of probability. We prove all of them. We shall prove all of them. Proof. For the first one, we say if phi is empty set, then P the probability of an empty set is equal to 0. It means that for any event, A is equal to A union empty set. So all we need to do is just to take our probability of A is equal to the probability of A union empty set, which is equal to the probability of A plus the probability of an empty set. It brings us to this point, which says that the probability of A, as we have written there, is equal to the probability, let's repeat it, plus the probability of an empty set, where the probability of an empty set is equal to 0. It means that the probability of A is equal to the probability of A plus 0, which is the probability of A. For the second one, the probability of the sample space 2. If A, C is complement of A, then the probability of A is equal to 1 minus the probability of A complement. Proof. S is equal to, that means the sample space is equal to A union A complement. So, like we have here, the probability of the sample space, the probability of S is equal to the probability of A union A complement. We know that the probability of A is equal to 1 minus the probability of A complement. So it simply means if we open this, we have the probability of S is equal to the probability of A plus the probability of A complement. And we know that this is 1, which is equal to probability of A plus probability of A complement. If we make this the subject, which is probability of A, we get 1 minus the probability of A complement, which we have stated here. And for the third one, 3. A and B are any two events. If A and B are any two events, we note that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. So we prove. We come over to this point. We should know that A union B is equal to A union B intersection C complement. Sorry, B intersection A complement and B, this B is equal to A intersection B union B intersection A complement. So the probability of A union B is equal to the probability of A plus the probability of B intersection A complement. We take this as our equation 1. Also, the probability of B is equal to the probability of A intersection B plus the probability of B intersection A complement. We take this as our equation 2. So all we need to do is just to subtract 2 from 1. We say subtract equation 2 from equation 1. We have this minus this. The probability of A union B minus the probability of B is equal to the probability of A minus the probability of A intersection B plus the probability of B intersection A complement minus the probability of B intersection A complement. So this will cancel this. We'll now be left with the probability of A union B is equal to the probability of A. We'll bring this over to this point. It will turn to plus. So we have the probability of B minus the probability of A intersection B. So this is how to obtain the proof of the 3 axioms of probability. For more of this, you need to subscribe to this channel.